I can probably touch on two problems in particular. The first one I mentioned already is the use of immunosuppressant. So it turns out that most of the cells implanted, up to 90%, die after implantation. So all we achieve is basically with a handful of cells. There is a recent publication only done in preclinical models, where it's been shown that if with the cells there are the additional cells are implanted belonging to the immune system, particularly a type of T cells called T regulatory cells, or Treg, it's been shown that these cells can have an effect locally in controlling the immune response. So it's possible in the near future we won't be implanting just dopaminergic cells, but also a variety of other cells of the immune system, so that they can have a more controlled local immunosuppressant, so that people don't have to take immunosuppressants. There are other ways. I mentioned the use of autologous cells, but there is also a better understanding, as I mentioned earlier, of how to manipulate genes. So another way is to create iPSCs, not expressing the HLA, so the surface antigen that are used by the immune system to detect what's not part of the body, and therefore trigger a reaction. This doesn't come with risks, though, because part of the job of the immune system is to make sure that tumorigenesis is not in place. And one of the biggest concerns of anybody receiving cells with such a capacity to proliferate is that these cells become tumor. So if you give cells with a sort of immunity against the immunitary system, there's a high risk that these cells can become neoplasm. The other point I wanted to touch upon is the misconception that Parkinson's is just a dopaminergic condition. In Parkinson's, we have a variety of different cells degenerating and a variety of other neurotransmitters degenerating, serotonin, acetylcholine. So fixing just a part of the brain is not enough. Fixing just a neurotransmitter is not enough. And maybe an easy way to explain this, you might recall I mentioned that the caudate degenerates in Parkinson's, and it keeps on degenerating because it's where we don't implant cells. The caudate is involved in a lot of executive processes, so cognitive, also in freezing of gait, most likely. And that's why it's been seen that in one of the early trials that Parkinson will do better in terms of fluctuations, motor symptoms, but the freezing of gait will keep on progressing because most likely the degenerate remaining neurons which hadn't been replaced.